Right. So it looks like we've got a ton of questions and articles here about basic machine learning models,
Yeah.
which tells me, you know, our listeners are ready to move past just the buzzwords, right? If we want to actually
Right.
understand how these things work.
Yeah, they want to get down to the nitty-gritty.
Exactly.
Yeah.
So that's what we're going to do in this deep dive. We're going to break it down model by model.
Oh.
We'll be covering linear regression,
Okay.
clustering, and decision trees.
Great topics.
Hopefully giving you the insights, not just to, grasp the concepts,
Sure.
but to actually think about how they apply to your world.
Yeah, that's a great goal.
Yeah.
I mean, it's one thing to read a textbook definition of an algorithm, but it's a whole other thing to actually see how these things could be used.
Yeah, or they could, yeah.
And trust me, even these simple models are being used in ways you might not expect.
That's awesome.
Yeah.
Well, let's start then with linear regression.
Sure.
I know it sounds a bit like, like something you'd find in a dusty textbook or something like that.
Like really academic and boring.
Yeah, exactly. But the idea is actually pretty straightforward.
Yeah.
Imagine you're trying to predict, let's say, how much a house is going to sell for.
Okay.
Based on how big it is.
Right.
So you plot a bunch of these data points, right?
Right.
On a graph, you'd have size on one axis.
Yep.
And then price on the other.
Okay.
And what linear regression does is it tries to draw the best possible straight line through that scatter plot.
Yeah, it's all about finding the relationship between those two variables.
Right.
One that we're trying to predict, the dependent variable, and then the one that influences it, the independent variable.
Okay.
So think of it like this. If you study longer, you probably expect to get a better grade, right?
Yeah, hopefully.
So in that case, your study time would be the independent variable, and your grade would be the dependent variable. So linear regression is trying to quantify that relationship and say, for every extra hour of study, your grade might increase by this much.
Okay, that makes sense.
Yeah.
But how does a straight line capture all the nuances of real world data?
Sure.
Houses, there's so many other factors impacting their price.
You're absolutely right. A straight line is a simplification.
Yeah.
But it's a really powerful one because it gives us a starting point, a way to see the general trend.
Okay.
And even this basic model is used constantly, in economics, to try to predict things like stock prices based on historical trends.
Wow.
In social sciences, to look at the relationship between income and education level or something like that.
Yeah.
Even in engineering, to analyze how different design choices impact a system's performance.
So you're telling me that linear regression could help figure out why a bridge might collapse?
Well, not quite that directly, but it can help analyze how different variables, like material strength, the design load, environmental factors, how all those things are interrelated.
Oh, wow.
By understanding those correlations, engineers can hopefully design more robust and reliable structures.
That's pretty amazing.
Yeah.
How something so seemingly basic can have these really complex applications.
It's all about understanding the dynamics, right?
Yeah.
Not just trying to predict a single outcome.
That's really cool.
Yeah.
Okay, so linear regression is about predicting trends.
Yeah.
But what if we want to find groups or patterns within our data?
Okay.
Without knowing what those groups should be?
Well, that's where clustering comes in.
Oh.
It's like sorting your socks, but instead of color or size, you're using these more complex data points.
Right.
Imagine trying to group customers based on their buying behavior.
Okay.
You might not know in advance what those groups are, but clustering algorithms can help you uncover those hidden segments.
So it's like giving the algorithm this jumbled puzzle and being figure out how these pieces fit together.
Exactly. And there's different ways to do that.
Oh.
Two of the most common are k-means clustering and hierarchical clustering.
Okay.
Think of k-means clustering like this. You decide you want to divide your customers into, say, 5 distinct groups, right?
Right.
The algorithm then has to figure out how to best arrange those groups so that customers within each group are as similar to each other as possible.
Okay.
Based on, whatever data you're using to define similarity.
Oh, okay.
It's almost like those magnetic sand toys where iron filings cluster around the poles of the magnet.
Okay, I can picture that.
Yeah.
But what about hierarchical clustering?
Sure.
That sounds a lot more complex.
Well, think of it as building a family tree, but for your data.
Okay.
It starts by treating every data point as its own little cluster, and then progressively merges those clusters together based on how similar they are.
Okay.
This creates this branching structure where you can see these different levels of relationships. So, for example, you might find that this broad group of, say, online shoppers, actually breaks down into these subcategories like,
Yeah.
frequent buyers, bargain hunters, and like impulse shoppers or something like that.
Interesting.
It's like creating a taxonomy to organize and understand these complex data sets.
So K-means is about like predefining the number of groups and finding the best fit.
Right.
Whereas hierarchical clustering is more like,
Builds up that structure organically.
it builds it up as it goes.
Yeah.
I'm guessing these have some pretty diverse applications.
Oh, absolutely.
Like where?
Well, marketing teams use clustering for things like targeted advertising and personalized recommendations.
Makes sense.
In bioinformatics, it can help identify genes with similar functions or disease associations.
Right.
And even in image processing, clustering can be used for tasks like object recognition, trying to figure out which pixels in an image belong to the same object.
So clustering is about uncovering these hidden relationships, like
Mm-hmm.
finding the order within what might just seem like chaos.
Exactly.
That's pretty powerful.
It is.
But what if we want to not just group the data, but actually make decisions based on it
Okay.
to predict an outcome, like whether someone will click on an ad or not?
Sure. Well, that's where decision trees come in, and they're super versatile.
Okay.
They can be used for both classification, so deciding what category something belongs to, or regression, predicting a numerical value.
Yeah.
And the way they work is actually really intuitive.
Okay. I'm intrigued. How do you make a tree out of data?
Well, imagine you're trying to decide whether to approve someone for a loan.
Yeah.
You might start by asking, do they have a good credit score?
Oh,
If the answer is yes, you follow one branch of the tree. If no, you go down a different branch. And at each branch, you ask another question,
yeah.
like what's their income level? Or do they have any existing debt?
Makes sense.
Each answer kind of guiding you further down the tree until you reach that final decision.
Like approve or deny.
Like a choose your own adventure,
Exactly.
but with data.
Yeah.
So it's like a flow chart, but instead of being designed by a person, it's generated from the data itself.
Exactly. And one of the best things about decision trees is that they're really easy to understand and visualize.
Okay.
You can actually see the logic behind the model's decisions, which isn't always the case with more complex algorithms.
Interesting.
Yeah.
Okay, so decision trees feel, I don't know, very logical.
Yeah.
Like a game of 20 questions, the algorithm's playing,
Right.
but the data.
Uh-huh.
But how does it choose which questions to ask, like which branches to create?
That's where it gets really interesting.
Okay.
The algorithm is actually designed to find the questions
Okay.
or the splits
Uh-huh.
that best separate the data into distinct groups
Okay.
or lead to the most accurate predictions.
Oh.
So, for example, if you were trying to classify emails as spam or not spam,
Yeah.
the algorithm might find that asking, does the email contain the word free? Okay.
Is a really effective split.
Because,
Because a lot of spam emails will, right?
yeah, they do.
But legitimate emails often don't.
Uh-huh.
Each split is like
Oh,
this
yeah?
strategic decision point
Yeah.
based on the patterns it's finding in the data.
So it's not just about like blindly following this preset path.
Right.
It's about like dynamically adapting
Yeah,
the questions based on what it's learning.
exactly.
That's pretty impressive.
Yeah, they're smart.
But I imagine it could get,
Sure.
pretty complex, especially with like huge data sets.
Yeah.
Are there any downsides to using decision trees?
There are a few things to watch out for.
Okay.
One is what we call overfitting,
Okay.
which is when a model gets so good at predicting the data it was trained on
Yeah.
that it doesn't actually generalize well to new, unseen data.
Huh. Interesting.
It's like memorizing the answers for a test
Oh,
instead of understanding the concept.
Oh, so you do well on like
Yeah,
the multiple choice, but you can't write the essay.
exactly. So how do we make sure that our decision trees don't fall into that trap?
Yeah. How do we make sure they can like
Yeah.
handle new challenges?
That's where techniques like pruning come in.
Pruning.
Yeah, imagine a tree that's grown too many branches and it becomes like really dense and tangled.
Okay.
Pruning involves like strategically removing some of those branches,
Okay.
the ones that don't contribute much to the overall accuracy of the model.
Okay.
This simplifies the tree, makes it more generalizable, and hopefully prevents it from getting too fixated on the training data.
It's like editing a piece of writing, right?
Yeah.
Sometimes you got to like cut out the extra sentences and little tangents to make the main point clearer and stronger.
Yeah, good analogy.
Okay. So overfitting is something to watch out for, but you can manage it.
Right.
What other limitations should we be aware of?
Well, one thing to consider is that they can be sensitive to even small changes in the data.
Really?
Like a few outlier data points or a slight shift in the distribution of values, and the entire structure of the tree can change.
Wow, so it's like they're a bit finicky.
Yeah, a little bit.
Easily influenced by their surroundings.
Right.
You need to make sure you're feeding them, you know,
Right.
a good diet of data, not just a bunch of junk food.
Exactly.
That'll throw off their system.
And while decision trees are great at handling that categorical data,
Like colors and types and
right, things like that,
categories.
they can struggle with perfectly linear relationships.
Oh, interesting.
If you're trying to model something that follows that really straightforward straight line,
Yeah.
linear regression's still going to be your best bet.
Okay, that makes sense.
Yeah.
It seems like choosing the right model is as much about like knowing its limitations
Yeah,
as its strengths.
absolutely.
You wouldn't use a hammer to screw in a light bulb,
Right.
just like you wouldn't use a decision tree to model a perfectly linear relationship.
Exactly. Exactly.
So this brings up a really important point that I think applies to all machine learning models.
Yeah.
The data quality.
The data, it's so important.
No model, no matter how fancy or sophisticated,
Right.
can magically like transform bad data into good insights.
Right. It's like trying to bake a cake with spoiled ingredients.
Yeah.
You might end up with something that looks like a cake,
Right.
but it's not going to taste very good.
Yeah, and it might even make you sick.
Exactly.
So garbage in, garbage out, as they say.
It's true.
So even before we start thinking about which model to use,
Yeah.
we need to make sure we're feeding it a good diet.
Absolutely.
What are some like key things to consider when it comes to data quality?
Well, first and foremost, I think you need to understand where the data is coming from and
Okay.
how it was collected.
Right.
Are there any biases in the collection process?
Oh, okay.
Is it representative of the phenomenon we're trying to model?
Makes sense.
And is it accurate and reliable?
Yeah.
So data clean, dealing with those missing values,
Mm-hmm.
transforming data into a format that the model can actually understand. All of that is crucial prep work
Right. It's like
before we even start building the model.
it's like prepping your ingredients before you start cooking.
Yeah.
You know, you wouldn't just throw a whole onion into a soup without like chopping it first.
No.
You got to clean it, peel it, dice it,
Exactly.
get it ready.
Yeah.
So data quality is essential.
Mm-hmm.
But let's not forget about the human element here.
Absolutely.
I mean, we're the ones choosing the models,
Right.
training them, interpreting the results.
Right.
We're the chefs. Right.
We are.
Not just the recipe followers.
Exactly. Machine learning is a powerful tool, but it's not a magic wand.
Yeah.
It's this collaborative process between humans and machines.
I like that.
Yeah.
So we bring our knowledge,
Mm-hmm.
our intuition, our ethical considerations to the table.
Right. And the algorithms do that heavy lifting of finding those patterns and making those predictions.
It's a partnership.
It is.
Fusion of like
Yeah.
human ingenuity and computational power.
I love that.
But that also means we can't just like blindly trust
Right.
the output of these models.
Absolutely not.
We need to understand how they work,
Yeah.
what their limitations are,
Right.
and how to, interpret their results responsibly.
Couldn't agree more.
Okay.
It's about using these tools thoughtfully,
Yeah.
critically, and ethically.
Mm-hmm.
And a huge part of that is being able to actually evaluate how well our models are doing.
Right. So how do we know
Right.
they're actually doing a good job?
Like, do we give them a grade?
Yeah. How do we
evaluate?
Right. That's where things get a little technical. But basically, we have to compare the model's predictions to what actually happened in the real world.
Okay.
Like, let's say we built a model to predict, I don't know, stock prices.
We would train it on this historical data and then test it on a period of like unseen data.
Right.
And we'd see how closely its predictions matched the actual stock movements.
Right.
And the closer the match, the better the model's performing.
So it's like giving it a practice run,
Yeah.
seeing how it does in a real world situation.
Exactly.
But how do you measure that, that closeness?
Right.
Like, are there specific metrics or scores or something?
There are. And
Yeah.
they vary a bit depending on the type of model and, the problem you're trying to solve.
Right.
But for regression problems like predicting stock prices,
Uh-huh.
we often use things like mean squared error or R squared.
Okay.
These basically tell us how much variation in the data is explained by our model.
Okay.
So the higher the R squared, the better the model is at capturing those underlying patterns.
So it's not just about getting a couple of predictions, right?
Right.
It's about how well the model understands the overall trend, the bigger picture.
Exactly. Exactly.
What about for those classification problems
Sure.
where you're trying to, categorize things like
Right.
spam or not spam?
Right.
How do you evaluate those?
Well, for classification, we often use metrics like accuracy, precision, and recall.
Okay.
So accuracy tells us what percentage of predictions were correct overall.
Okay.
Precision focuses on how many of the positive predictions were actually true positives.
Okay.
And recall measures how many of the actual positive cases were correctly identified.
So it's kind of like this
Yeah.
three-pronged approach, right?
It is.
Looking at all these different...
Facets of the model's performance.
But it sounds like, evaluating these models is a bit more nuanced than just saying pass or fail.
It really is.
It's more about
Yeah.
understanding its strengths and weaknesses and seeing where it might need improvement.
It's an iterative process. You build a model, you test it, evaluate it, tweak it, and repeat.
It's like fine-tuning a musical instrument.
It is.
You keep adjusting until you get the sound that you're looking for.
Exactly.
Well, and just like a musical instrument, a well-tuned machine learning model can create amazing results.
For sure.
So let's talk about those results.
Okay.
We've covered kind of the basics of how these models work.
Yeah.
Where are they being used out there in the real world?
Oh, that's a great question. They're being used practically everywhere you look.
Give me some examples.
Well, think about your smartphone, like facial recognition, voice assistance, personalized recommendations, all powered by machine learning.
Okay, so they're already integrated into our lives in ways we might not even realize.
Yeah, behind the scenes.
What about beyond our phones, though?
Sure, well, in healthcare.
Yeah.
They're being used to diagnose diseases earlier and more accurately,
Wow.
to develop new treatments, and even to personalize patient care.
That's amazing.
Finance, they're helping detect fraud, assess risk, make those more informed investment decisions. Yeah. Self-driving cars rely heavily on machine learning algorithms to, navigate those roads and avoid obstacles.
It's mind-blowing to think about how many, different applications there are.
I know, right?
From something as personal as our phones to something as, complex as an autonomous vehicle.
It is.
It seems like machine learning is
It's changing the world.
yeah, it's quietly revolutionizing so many things.
It really is. And as the field keeps advancing, we can expect to see even more innovative and transformative applications.
Like what?
Think about things like personalized education, where learning experiences are tailored to each student's needs and abilities.
Okay.
Or smart cities, where machine learning is helping to optimize traffic flow, energy consumption, public safety, all sorts of things.
It sounds both exciting and, I don't know, maybe a little daunting too.
Yeah, a little bit of both.
With all this power comes a lot of responsibility, right?
Absolutely.
We need to make sure that these models are being used ethically and for the benefit of all.
Right. Not just for profit.
Right. Not just for the select few.
Right. Exactly. It's
Yeah.
about using these powerful tools to hopefully create a more just, equitable, and sustainable world.
Well, that's a great point to end on.
Yeah.
This deep dive has, given us a glimpse into the world of machine learning models, but it really is just the beginning.
Yeah, the tip of the iceberg.
So much more to learn and explore and create in this, rapidly evolving field.
Absolutely.
So to our listeners, I encourage you to,
Stay curious.
stay curious, keep asking questions, and just never stop learning.
Yeah.
The future of machine learning is being shaped right now, and it's up to all of us to be informed, engaged, and thoughtful participants in that process.
Couldn't have said it better myself. Keep exploring, and we'll catch you on the next deep dive.